So how many of here would like to know why they have Parkinson's disease? How many would like to slow it? And how many would like to reduce the risk of your children ever getting this disease? All right, how about that? So we're going to give you answers to each of these questions. I'll give you a little preview. The answers are a little uncomfortable. They're a little disturbing. They're a little, they actually get me upset, but that's why I'm here, to try to get the word out that Parkinson's disease, for the vast majority of individuals with the disease, is largely a man-made disease. So all the people here in Boston had a pleasure to get a copy of our book called The Parkinson's Plan. The book's available on Amazon or wherever you'd like to get your books. So as many of you know, Parkinson's disease is one of the world's fastest growing brain disease. The first major description of Parkinson's disease was by a 61-year-old surgeon who noticed something new, something different on the streets of London while just casually walking. And what Dr. Parkinson saw was he saw tremor, which had long since been described, but he saw this stoop posture, this shuffling gait, this tendency to walk forward and faster and faster and to fall forward. And he said this condition, he said, had not been described in the medical literature. So he described 6 individuals in 1817 with a condition that he says has not been described in the medical literature, was not in the nosology of the times. 200 years later, the Global Burden of Disease study estimates that 6 million people have the disease. So how do you go from a disease that Dr. Parkinson's largely thought was new, not described in the medical literature, affecting 6 people on the streets of London, to one affecting 6 million people around the world? It can't be genes, principally, because our genes don't change that much in the span of 200 years. It can't be aging alone, because it's growing faster than aging, and no other disease looks like this. Not Alzheimer's disease, not stroke, nothing else, no other brain disease looks like that. And I think the principal causes of Parkinson's, not the only, the principal causes of Parkinson's disease are chemicals in our food, water, and air. And then when Michael Oken, who wrote the book with me, is a fellow Parkinson's specialist at the University of Florida, when he and I look at this slide, this graph, we see this as our report card. So we're in Boston, lots of people care about report cards in Boston. This is not a good report card. And it's the number of people with Parkinson's disease, the Global Burden of Disease study estimated last year that nearly 12 million people have the disease. So David said some nice things about me in the introduction. If I've done all these great things, why is Parkinson's the fastest growing brain disease on my watch? And I find that deeply unsettling. My colleagues have answered the bell when it came to HIV. My colleagues have answered the bell when it came to polio. My colleagues answered the bell when it came to COVID-19. My colleagues answered the bell for stroke. The incidence of stroke in the United States has dropped by 30% in the last 30 years. But we have not answered the bell when it comes to Parkinson's disease, and that leads, to my mind, to a lot of needless and preventable suffering. And so Michael and I want to take an action, and so we outline in the book, it's called The Parkinson's Plan, because we actually give you a plan to, 1, prevent the disease, 2, to learn why the disease begins, 3, to amplify the voices of everyone in this room, because the course of diseases are changed most powerfully by people who are most directly affected by the disease. In the words of Michael J. Fox, Parkinson's disease sucks. And you guys know that viscerally, right? And you know that intimately. And if you make your voices heard, you can help make it so that future generations don't get stuck with a disease that sucks. And then finally, all of you want better treatments, and David is working on better treatments in his lab. And in chapters 8 and 9 of the book, my colleague, Dr. Michael Oken, tells you what are the most promising treatments in the near term, midterm, and long term for Parkinson's disease. So when I was in medical school, I was taught that Parkinson's disease was some function of aging, some function of genetics, some function of bad luck, and maybe a word about pesticides. And I'm going to tell you what I was taught was largely wrong. Parkinson's disease does increase with aging, and longevity is important. If everyone died at 40, like in Brave New World, no one would get Parkinson's disease, no one would get Alzheimer's disease. But the incidence of Parkinson's disease, which is on the y-axis, and age, this is the graph for Parkinson's disease. This is from the United Kingdom. This is generally what it looks like for most parts of the world, but not all. extraordinarily rare before age 30, and the incidence, the number of new cases of Parkinson's per 100,000 people, triples every decade. And in most parts of the world, including the United States and the United Kingdom, but not every part of the world, it's more common in men than women. And so this is the graph that I was shown in medical school. Professor Simon has likely included it in papers that he's written. This is what everyone thinks is what's causing Parkinson's disease. But this is the exact same graph for lung cancer. So does aging cause lung cancer? No. And so in 1900, lung cancer in Boston essentially did not exist. Lung cancer, the leading cause of cancer death in the United States, leading cause of cancer death in the world, largely just did not exist in 1900 Boston. When doctors encountered a case of lung cancer, they thought it was a once-in-a-lifetime outing. They'd gather all the doctors and medical students around, thinking that they would never see another case. Unfortunately, they were wrong, because 25 years after cigarettes were introduced, you see a corresponding rise in lung cancer. Smoking in the United States peaks in the 1970s. 25 years after the peak, you see a corresponding decline in lung cancer. Now, a couple other things. Lung cancer extraordinarily rare before age 30. If everyone died at age 40, almost no one would get lung cancer. Triples every decade beginning in the 30s. In most parts of the world, it's more common in men than women, and that's because more men than women smoke cigarettes. I think in the United States and the United Kingdom, as I'll talk about the chemicals, more people are exposed to these pesticides. For example, in the United States, 75% of farmers are men. 97% of pesticide applicators are men. The other thing is, you don't smoke a cigarette at 58 and develop lung cancer at 60. You developed lung cancer at 60 because you were exposed to to cigarettes when you were in your teenagers and 20s. I think for most people with Parkinson's disease, and this hasn't been well studied, but I think for most people, the seeds of Parkinson's are planted early. So it's exposures to chemicals that you had as a child, when you were a young adult in your 20s, that set you up for disease that manifests with tremor and slowness of movement decades later, 20, 30, 40 years after the fact. Good so far? All right, so that was aging. So longevity is important, but it's not a function of just longevity. If you put a mouse in the laboratory, it will never spontaneously develop Parkinson's disease, or for that matter, Alzheimer's. David will correct me if I'm wrong, but it doesn't. The only way it does is if you expose it to chemicals or manipulate its genes. So what do we know about genes? So there's a great study called PD Generation in the back, led by the Parkinson's Foundation. Just met Kyle. It's a fantastic study. It offers free genetic counseling and genetic testing to anyone with Parkinson's disease in the United States, and I think in 8 or 9 additional countries. How many people have participated in this study? So wow. And then of those, so it offers genetic testing, genetic counseling. How many of you tested positive for genetic cause or risk factor? So there you go. So we did the results. So these are the results from the first 8,000 individuals. It was published in one of our top journals called Brain just last year. And they looked at 8,000 individuals with Parkinson's disease, and of those 8,000 individuals with Parkinson's disease, 13% carry a genetic cause or genetic risk factor. So these genetic causes and genetic risk factors are important because they help us understand the pathophysiology of Parkinson's disease. They open a gateway for studying in the laboratory. It's relatively easy to manipulate the genes and study in the laboratory, and you can identify gene-targeted therapies. And some of you know these genes. The most common genetic cause is mutations in a gene called LRRK2, and the most common genetic risk factor is in a gene called GBA. These individuals appear in recent research to be at increased risk for Parkinson's if exposed to pesticides, for example. But the most important part of this slide is this. 87% of Americans with Parkinson's disease do not carry any known genetic cause or genetic risk factor for the disease. The vast majority of Americans with Parkinson's disease do not carry any known genetic cause or risk factor for disease. Now, these are the genetic causes. There are other genetic factors that explain, for example, why some people might get disease when they're exposed to a chemical and why some don't. But the principal causes of Parkinson's disease do not lie within our bodies. They are not in our DNA. They are not in our cells. They are outside of us in our environment and chemicals in our food, water, and air. So what are these chemicals? They vary. There's a long list. I'm going to highlight three I think are the most important for people in this room, especially the top two, and that I think are most important for people in the United States. So the first one are certain pesticides. How many of you heard about paraquat? Fantastic. So paraquat is a weed killer. It was created in the United Kingdom in 1962, in the United States in 1963. It kills the weeds that Roundup doesn't. It's so toxic it's been used to commit homicide and suicide. And my colleague, Dr. Caroline Tanner, in 2011 showed that farmers who work with paraquat have a 150% increased risk of Parkinson's disease. My colleagues, Drs. Beata Ritz and Kimberly Paul, in 2023 showed that simply living or working near where paraquat is sprayed doubles your risk for Parkinson's. So you don't have to be the smoker to be affected, be at increased risk. You can simply be a person breathing in secondhand, not smoke, but secondhand pesticide exposure and have an increased risk of developing Parkinson's disease. Over 50 countries, including China, have banned this chemical, but the United States has not. England bans paraquat in the United Kingdom, but exports it to Mexico and the United States. And the use of paraquat in fields in Massachusetts and almost every state in the Union is increasing. For the data from the U.S. Geological Survey, the amount of paraquat sprayed on U.S. farms has doubled in the past 5 years. But that's not the only pesticide that links to Parkinson's, and not all pesticides are. Another one is called chlorpyrifos. Anyone? Chlorpyrifos? So if you've ever eaten an apple, it's very likely that apple was sprayed with chlorpyrifos. Over half of apple orchards in the United States were sprayed with chlorpyrifos. It was used to spray inside the homes of people in New York City to kill insects. My colleague, Dr. Virginia Rao at Columbia University, looked at the children born to women where the pesticide was sprayed in their indoor air. She finds the pesticide in the umbilical cord blood of those children. Then she followed these children, and the children who had the higher levels of chlorpyrifos in the umbilical cord blood had lower IQ at 3, 5, and 7. Chlorpyrifos is a neurotoxin. And then last month, she published research results looking at the brains of those children who were now ages 6 to 15. The higher the level of chlorpyrifos, the more structural brain abnormalities on MRI, and the slower their motor function. It's also widely sprayed on golf courses. My colleague, Dr. Brittany Krzyzanowski, did a study just published earlier this year showing that individuals who live within 1 mile of a golf course in Rochester, Minnesota, had a 126% increased risk of developing Parkinson's disease. This chemical was banned by the EPA in 2021, but its manufacturer sued, and it's still allowed to be sprayed on apple orchards today. The second class are chemicals called trichloroethylene and perchloroethylene. People know trichloroethylene? So a couple. So trichloroethylene is very simple. We're going to do a little chemistry lesson. We're in Boston, so you're all smart. So you all remember that water is made up of 3 atoms, H2O, 2 hydrogens, 1 oxygen. Trichloroethylene, I keep it with me wherever I go, is made up of a whopping 6 atoms. It's got 2 carbon atoms in black, 1 hydrogen in white, and 3 chlorine atoms in blue, hence its name, trichloroethylene. It's got a cousin, it's called perchloroethylene. It's got 1 additional chlorine atom. Anyone ever had their clothes dry clean? So you've been likely exposed to perchloroethylene. Dr. Tanner and her colleague, Dr. Sam Goldman, did a study in 2013, I believe, looking at twins from World War II. And they looked at twins who had hobby or occupational exposure to trichloroethylene or perchloroethylene versus those without. Those who had exposure had a 500% increased risk of developing Parkinson's disease. It's also, perchloroethylene is still widely used in dry cleaning. One thing you're going to do after this is you're going to find a green dry cleaner. so you just stop getting exposed to this chemical. And as I'll tell you, there's contaminated scores of sites around the country. Many people, I think, know about Camp Lejeune. This is a Marine base in North Carolina. From 1953 to 1987, 1 million Marines, their family members, and civilians were exposed to this chemical in their drinking water. Doctors Tanner and Goldman looked at these individuals who, by and large, are healthy, right? If you're a Marine, you're pretty healthy. By and large, young, average age 20, some were teenagers. They were only there for a relatively short period of time, just over 2 years. If you're a Marine, you move around. Yet 34 years later, on average, they had a 70% increased risk of developing Parkinson's. And the last one is air pollution. Air pollution, when you see air pollution, what you're actually seeing is little pieces of dirt and soot, and they're suspended in the air. The scientific term for those pieces of dirt and soot is particulate matter. And these particulate matter have some dangerous hitchhikers. Lead from leaded gasoline, iron from brakes, platinum from catalytic converters. Most of this particulate matter is large enough that we cough it out or sneeze it out. But some is so small, 1/30 the width of my hair, that it penetrates the nerve responsible for smell, called the olfactory nerve, hanging up in our upper nasal passages, and can penetrate the nerve directly and go back to the smell center of the brain. And many of you know that the pathology of Parkinson's disease, we think for most individuals, not all, most individuals with Parkinson's disease begins in the smell center. And many of you know one of the earliest features of Parkinson's disease is loss of smell. And it turns out that the pathology of Parkinson's disease can spread from nerve cell to nerve cell. And you can go from the smell center of the brain back to the substantia nigra, the part that's affected with Parkinson's that gives you tremor and slowness of movement, with just one stop in an area of the brain called the amygdala. The other thing, and this is work Dr. Simon has been working on for a very long time, is that all of these chemicals damage the energy-producing parts of the cells called the mitochondria. And Dr. Simon's done lots of work with genetic forms of Parkinson's disease, showing that most of the genetic forms of Parkinson's disease also have damage to the mitochondria. So in many ways, these environmental causes are mimicking the genetic forms of the disease. And many of you know that your brain is only 2% of your body weight, but 20% of your energy consumption. And neurons, nerve cells, especially those in the part that are damaged by the brain, are chock full of mitochondria, making them likely especially susceptible to these toxic chemicals. Is that good? So this is a paraquat. So you can see that you're not spared of paraquat by living necessarily in Boston or Massachusetts. It's sprayed throughout the United States. This is the most recent data available, at least via the U.S. Geological Survey. And you can see use of paraquat in the United States is not falling, it's not receding, but increasing. And it's sprayed on fields of corn, cotton, soybeans, and vineyards. And this is a trichloroethylene. That's its chemical structure, widely used in degreasing metal. And so you can get exposed to it through one of two ways. One, you can work with it, or two, you can get exposed to it in your environment. And in 1970, it's estimated that 10 million Americans worked with this chemical. 10 million Americans worked with the chemical. It's estimated that 1 in 12 workers in the United Kingdom worked with it. And so you're like, well, who works with TCE? Not surprising, if you're an aircraft or jet engine mechanic, an automobile worker, a computer specialist, a dry cleaner, a painter, a printer, a varnish worker. I met someone in the back who worked in photography, widely using that. These are all individuals been exposed to it. And then almost all of us have been exposed to it through its commercial or consumer uses. So if you've ever cleaned a carpet or cleaned a gun, you've likely been exposed, you've been possibly exposed to trichloroethylene. If you were young enough to remember typewriter correction fluid like me, you might have been exposed to trichloroethylene. If you drank decaffeinated coffee in the 1970s, you may have been exposed to trichloroethylene. And then it's got a wide amount of industrial uses. In 1970, 2 pounds of TCE were produced per American in the United States. And then Superfund sites, these are the most toxic sites in the country that are designated for federal cleanup. Over half of Superfund sites in the country are contaminated with trichloroethylene. So the number one reason for contaminated Superfund sites in the United States is trichloroethylene. Historian buffs will remember Love Canal up near Niagara Falls was the first contaminated site. It was contaminated with trichloroethylene as well as a whole slew of other chemicals. You can see that Boston, Massachusetts has more than its fair share of these contaminated sites. And one of these sites is actually among the most famous in the country. How many people know about, have seen the civil action? So this is Gowanus Canal, not Gowanus Canal, this is, this is Woburn, Massachusetts, where trichloroethylene, often stored in 55-gallon drums, contaminated the drinking water in Woburn, Massachusetts, just north of here, with trichloroethylene as well as other chemicals. According to the EPA, trichloroethylene is carcinogenic by all routes of exposure. That means that trichloroethylene causes cancer. And 12 cases of childhood leukemia were found in East Woburn, Massachusetts, as depicted in the book. There's a book and a movie, excellent movie, and even better book. Women would bring their children to Boston Children's with leukemia, and they'd say, doctors, Johnny's not the only one with leukemia, but Mary and Susie up the street have leukemia. Could it be something to do with the water? The doctor says no, the moms are right. And then there was an extensive cleanup and a legal settlement, and lots of that discussed in the book. I kind of wonder, and maybe David can help me out here, if anyone grew up in Woburn? Is that I would suspect that this population might be at high risk for Parkinson's disease, 30 years after the fact. So the people who survived cancer, for example, might be at higher risk for developing Parkinson's disease. If anyone knows about this, please let me know. I'd love to learn. And the last one is air pollution. This is just a map of air pollution in the United States, the map of that particulate matter, the little pieces of dirt and soot. And this is the map of the incidence of Parkinson's disease, depending on your eyes and your perspective. I think you can see a relationship. And this has borne out by research done by Dr. Brittany Krasnowski and Dr. Brad Rissett, who showed that areas of the country with high levels of air pollution are more likely to have high rates of Parkinson's, and areas of the country with low rates of air pollution are more likely to have lower rates of Parkinson's disease. So that's all the disturbing part. Maybe you'll tell me afterwards, or maybe in the Q&A. I'd love to learn if you think you might have been exposed to any of these chemicals. Did any people think they were exposed to any of these chemicals? Wow, wow, wow. So in the book, we give you the Parkinson's prevention pyramid. What are ways that you can prevent or slow the rate of progression of the disease as individuals? What can you do in your community to prevent or slow the rate of progression in your community? And what can we do as societal action to prevent or slow the disease? So in the book on page 237, you can jump ahead. We give you the Reader's Digest version. We give you 25 actions that can reduce the risk of Parkinson's and possibly slow its progression. And then we give you suggestions on what you can do in your community. So I found out in the process of writing this book that pesticides are routinely sprayed on kids' schools and playgrounds. Did people know this? Yeah, so I didn't know this either. So in not too long ago, a woman, Robin Sewell, dropped off her 5-year-old child at Sherman Oaks Elementary School in Los Angeles. A man in a hazmat suit is spraying the hedges with pesticides. Her 5-year-old son has an asthma attack in front of her. He goes back to her and he goes, "Mommy, Mommy, is this ever going to happen again?" And she said, "No." And because she said no, California passes the Healthy Schools Act, which bans the use of most toxic pesticides on schools, playgrounds, and grounds, and requires that if schools do spray pesticides on this school or sports fields, that they notify the parents in writing in advance of such spraying. So if Robin Sewell can do that in Los Angeles and California, what can you do in Boston? What can we do for golf courses? If people like to play golf, can we contact the golf course and say, can we spray less pesticide? Can we make sure we're spraying pesticides that are less toxic? Can we spray less frequently? I think all of us would be willing to have greens that are 10% less green in return for decreasing our risk of Parkinson's disease or the risk of progression of the disease. There's a study done by my colleagues, Dr. Beata Ritz again at UCLA and Jeff Braunstein, showing that people who already have Parkinson's disease, who are exposed to pesticides after their diagnosis, have a faster rate of progression of the disease on almost every domain that they measured. And then can we ban these chemicals and stop subsidizing the use of pesticides? The two crops that are subsidized the most in the United States are corn and soybeans, and the two crops that are sprayed with the most paraquat in the United States are corn and soybeans. So this is the Parkinson's 25. This is your Reader's Digest version. If you're not a big reader, you can just jump to page 237. I will not be offended. And we give you 25 ways to possibly slow your rate of progression, reduce your risk. Number 1 is to wash your produce, even your organic ones. Pesticides have contaminated our food supply. Remnants of pesticides are found in 20% of common foods. Organic produce, dairy products, and meat can reduce exposure, but can still have unsafe residues of pesticides. So wash your produce at least with water, and consider simple vegetable washes, vinegar, or salt solutions too. And then we give you a bunch of other recommendations. We talked about the Mediterranean diet, low in animal products. Animals might, when you eat an animal, you're not just eating the animal, but you're eating what the animal ate. And sometimes the animal concentrates these toxicants as they make it their way up the food chain. And we tell you about how trichloroethylene or perchloroethylene can evaporate from dry cleaning stores and be found in the butter and in the cheese in grocery stores in Germany. Give you suggestions about air purifier. No one's poisoning themselves. I'll read this one. Sometimes the remedy is worse than the disease. Insects, including fleas, ants, and moths, can be unwanted guests. Unfortunately, some common pesticides can increase the risk of Parkinson's. For example, the pesticide permethrin found on flea collars, ant sprays, mothballs, and outdoor apparel can reduce dopamine-producing nerve cells in laboratory animals. Consider safer alternatives, and if necessary, minimize exposure by wearing a mask, increasing ventilation, and avoiding spraying near children, and dry cleaning cautiously. So that's what we have to do to prevent or slow the rate of progression of the disease. The second is we need to learn why the disease begins. Everyone here wants a cure for Parkinson's. The prerequisite for curing a disease is knowing its cause. The prerequisite for curing a disease is knowing its cause. David will help me out, but I can't think of a disease that we can cure medically where we don't know its cause. Right? We can cure certain pneumonias or certain skin infections. We can cure peptic ulcer disease. We can cure hepatitis C. We can prevent polio. But we can do all these things only after we identified what the cause of the disease is. But right now, only 2 cents of every Parkinson's research dollar is spent on trying to prevent Parkinson's. Only 2 cents. 60% of biomedical research funding in the United States is by industry, by pharmaceutical companies, medical device firms that are trying to develop better treatments, and we need better treatments. But those pharmaceutical companies, they benefit from the more people that have the disease because there are more sales. And so they're not oriented towards preventing the disease. And even foundations, many foundations are founded by people with the disease, and what do people with the disease generally want? They want better treatments or a cure. But to cure a disease, we need to first figure out what its cause is. It turns out that there are homes in New York City, where I now live, and likely in Boston, that are sold for more money every day than we as a society spend on trying to prevent Parkinson's disease. And we wonder why 200 people will be diagnosed with Parkinson's disease on Monday, and why 100 people with Parkinson's disease will die from the disease today. If we don't find the cause, if we don't orient ourselves to trying to prevent or slow this disease, only more and more people will be affected. We know that the economic burden, beyond the human burden, the economic burden of Parkinson's disease is high. It turns out it's about $50,000 per person in this room affected with the disease. Half of that, about $25,000 from incremental costs to Medicare, drugs, doctor's visits, physical therapists, and about $25,000 in terms of lost wages, disability, out-of-pocket expenses, caregiver support. If we prevented only 1% of Parkinson's disease, the economic benefit would be $500 million per year, 1%. So if I'm off my rocker and I'm only 1% right, that only 1% of Parkinson's is preventable, that's $500 million. What's $500 million? That's double what the National Institutes of Health spent on Parkinson's research last year. That's more than the Michael J. Fox Foundation, the world's largest funder of Parkinson's research, spends annually. That's more than the global sales, not profits, global sales of Paraquat. The U.S. Treasury, the country would be better off if the U.S. Treasury cut a check to the makers of Paraquat for $400 million and told them to stop spraying it around the world. We would come out ahead. To make that change, we need to amplify our voices. There are 1.2 million people with Parkinson's disease in the United States, but unfortunately, I think we've been too silent. My friend and colleague, Ali Signorelli, who is a woman with young onset Parkinson's disease, she says that Parkinson's got a PR problem. And in 1987, activists in New York City, men, largely men, but some women, with HIV formed an organization called ACT UP, led by the late Larry Kramer, and their motto was silence equals death. Because in the 1980s, silence for people affected with HIV did equal death. There was no federal response. Doctors refused to treat. Some doctors refused to treat people with HIV. Some of the country's most prestigious hospitals refused to admit patients with Parkinson's disease. President Reagan was slow to recognize the issue. But they changed the course of HIV. They were formed in 1987. By 1995, we had protease inhibitors, which allowed people with HIV to live lives with near normal life expectancy. The incidence of HIV in the United States today is at its lowest level since 1990. HIV is preventable with a condom. More people receive appropriate treatment for HIV in this country and around the world than they do for Parkinson's disease. And that's because these individuals made their voices heard. In 1980, a 13-year-old girl in California was struck crossing the street with her friend. She was struck by a drunk driver. 4 years after her daughter dies, Ms. Candace Leitner finds her voice, petitions the governor of California every day for a year. In 1980, drinking and driving is legal in some states in the union. 8 years later, drinking and driving is illegal in all 50 states. Drinking age is raised from 18 to 21. Blood alcohol levels drop to 0.08. Because of Candace Leitner, because of MAD, thank you to those of you that are members of MAD, 10,000 fewer children, 10,000 fewer families, 10,000 fewer communities are torn apart every year. Every year, 10,000 people less are killed just in the United States alone because of Mothers Against Drunk Driving. And then in chapters 8 and 9, Dr. Michael Oken tells you what are the most promising treatments in the near term, including levodopa pumps. What are some of the most promising treatments in the midterm, including sensing deep brain stimulation? What are some of the most promising treatments in the long term, including little nanobots that can deliver anti-inflammatory medications to the brain? And then, as Dr. Simon indicated, I work in New York City for a new center focused on the brain and the environment. Our goal is to identify the environmental causes of brain diseases from autism to Alzheimer's disease. In the world today, the leading cause of disability globally is not cancer, it's not heart disease, it's not infectious diseases, it's not COVID, it's brain diseases. For 99.9% of human history, that's never been the case. And I think that chemicals are fueling the rise of not just Parkinson's disease, but a wide range of brain diseases. If you're interested in learning more, supporting our efforts, we would welcome it. We want to measure chemicals in people's bodies, so can we measure these pesticides, dry cleaning chemicals in people's bodies, including now by looking at their blood, hair, and urine? Can we measure these chemicals in your environment? What's in your food, water, air, soil, household dust? And can we identify clusters of brain diseases? If you're interested in participating in any of this, you can scan the QR code that should be right next to you. Or if you're not tech savvy and you like pen and paper like me, we have a little sign-up sheet in the back. And to sign up for our brain registry, no obligation, free to do so. You can also sign up for our free newsletter. So what can we do like right now? So hopefully we've motivated you. So what can you do as individuals? So one, you can join the PD Avengers. This is a global grassroots organization of people with Parkinson's disease, led by people with Parkinson's disease. It takes 30 seconds to join. Anyone can join, with or without Parkinson's disease, your children, your neighbors, your nephews, your nieces. pdavengers.com, or scan this QR code. Takes you 30 seconds to do. 10,000 members in over 100 different countries. You can sign up for our registry, and then you can tell a friend or 10 about our book, The Parkinson's Plan. It made its way onto a New York Times bestselling list, but that means that only about 30,000 copies have been sold. That means only 3% of people with Parkinson's in the United States know about the ways that we can prevent or slow the disease. We want everyone to know about that, so we would love your help in trying to get the word out. You can, in your communities, advocate for pesticide-free or golf courses in schools. At the EPA, at the national level, you can contact the EPA administrator. His name is Lee Zeldin. His email address is zeldin.lee@epa.gov. And you can email the administrator and go, "Dear Administrator Zeldin, thank you very much for your service. Can you please ban paraquat, chlorpyrifos, and make sure that the bans that have been instituted on trichloroethylene and perchloroethylene are implemented?" If 1.2 million Americans email their EPA administrator or their local representative or their senators, Senator Ed Markey is one of the principal persons who's been representing Woburn, Massachusetts, and one of the reasons that in 2024 the EPA banned trichloroethylene and perchloroethylene is because of Senator Ed Markey. But in 2025, that ban was frozen, and the fate of that ban is uncertain. You need to make your voices heard so that we prevent these diseases. You need to make your voices heard so we prevent these diseases. We've received some gifts that I've talked about, alluded to. Some of you are young enough to have participated in the March of Dimes, which began in 1938. 17 years later, Jonas Salk held up the vaccine for polio. So we live in a world largely free of polio. In 1980, we saw what Candace Lightner did to change the course of drinking and driving, which is now socially acceptable. We live in a world where HIV is both preventable and treatable. These are all gifts that we've received from previous generations. We're now coming upon the holiday season, and I suggest to you it's time that we reciprocate, that we create a world where Parkinson's is increasingly rare instead of increasingly common. As a neurologist, I can't think of a better gift than that. Thank you very much.